so we'll have either groups of 4 or 3. So if your person's not gonna be here, then you're gonna be a group of 3. Alright, so I'm gonna give you an assignment, but before I do, I want you to walk through what you're gonna do here. And I had this paper. So the first thing you need to do is fold this into 3 pieces. 3 equal sections, because the assignment has 6 problems on it. So each section, fold that into 3, that's your good paper. You're gonna do scratch work on your own, and then fold that into 3 equal pieces. So we'll have 3 on one side and then 3 on the other, a total of 6. There's, the first 3 are the same type of question, and the second 3 are the same. So what I want you to do, after you fold it in 3, write 1, 3, and 5 on one side, and then 2, 4, and 6 on the other. 1, 3, and 5 on this first side, 2, 4, I don't care. You can do it either way. So that way you'll do one side first, I don't care which side you pick. That way you'll do a few of everything. Alright, so we're gonna go over these instructions and I'm gonna leave them on the board so that you can look at them. But let's go through them together first. We'll wait till everybody's ready to look up here. Alright, so I want you to read the question, so maybe one person's gonna read it out loud to the group, and then I want you to talk about the question. And again, this is only gonna take 10, 15, 20 seconds, whatever. But I want you to follow these steps so that they help you when you're working the problem. I want you to write down the steps to solve the problem. And then I want you to, so you're gonna say what you're gonna do, then you're actually gonna go do it first. So I want you to take the time first to think about what should be happening. So for example, let's say I asked you to find a minimum. Here's what you would, some steps that you could write down. And I don't need a lot of words, you could be brief as you want, but to find a min, I need to take the derivative, set it equal to 0, define critical values, make a sign chart, pick between the positives and the negatives. Or something along those lines, right? A min would be what? Positive to negative or negative to positive? Negative to positive, good. Okay? So you'd write those words down, then you'd work out the problem. That's what I want on the white sheet, okay? Circle your answer, pat yourself on the back here. Go to the next problem. So do either the odd ones first or the even ones first, so you try a couple each of different types. I will come around and answer questions, maybe with a question. Okay, who has logistics questions right now first before we start? Yes.
So last year, the only things going, there's the steps that we take,
All
and then
all
the answer.
this, 3 and 4 and 5 will be on that white sheet of paper. Right, 1 and 2 are kind of out loud in the air. Okay, so you want to write down the steps, you want to do the steps, circle your answer. Okay, any other things that we need to clarify? All right, the questions are in Schoology, so one person needs to get their computer. It's called Functions Defined by Integrals 2. Also, I have the key, so I will come around and check when you finish a problem.
Why would you go?
So I'll answer questions, I'll check work. We need at least one computer, but you can all have your own now. Functions defined by integrals 2. It's either at the very bottom or at the very top. No, it should be in the function defined by integrals. Yep. Yep. Is it on top? It's the first one in the folder. Ready? Where's your scratch pad? Where's yours? What do you mean? What are you doing? You know, really. You could get a marker and an eraser, or at least a scratch sheet of paper. And it's the pencil. They're ready going down.
Yes.
Yes, we'll start with.
So MX. All the way. Can you scroll up? Scroll up.
Yeah, like that. It's like that.
I can't see it.
Okay.
And if you need a little nudging.
MX.
Hey, I got it.
So we're This we have to do our second fundamental theorem, right? Where first we start
Oh, yeah, that's right.
by.
Yeah, we have to give the top one question, okay.
2x, right?
So the first step is we replace x replace t with x, and then multiply what's it called, the integrand? Multiply the integrand by the derivative of the upper bound.
Do we though?
Yeah, that's the
Because
second.
there's a difference, because this first one is m to this, and then this one.
Yeah, I know, this gives us what our second derivative is, and then we plug that
I'm pretty
into
sure
our
you could
end.
have taken B if you wanted.
Trust me, it'll work out. It'll work out once we start solving.
Yeah.
Cause here, if you
What's the step where we say it real quick? Which one?
it's gonna be
Alright, check, check answers or help you along. Either of those things.
Yeah, it would be.
Yeah, we have Yes, that's, yeah, that's fine.
And then like on derivative.
Okay.
Now we're on this. It's like find this
Did you use chain rule?
What? No, you multiply it
So
by.
that is the second dimension of calculus. It's like the two.
Yeah.
Yeah. Okay, and then so we replace t with x, and then we separate, plug it into the integrand.
But there's nothing to solve. It's just like, isn't that what we're doing?
Yeah, that's this.
So isn't that replace? Isn't that what we did?
Yeah, that is what we did when we replaced this.
I mean, yeah. Good luck, man. And then, we multiply that by the derivative of the
Sorry,
and now, so we have our x.
So this one, I'm not always gonna be
So it'd be 2 times.
I know what I'm saying, it's not as if he hasn't been live. Okay.
But that's how you get, yes, that's that. That's not
If
what-
it's a
Wait,
subtraction.
don't we have to put the half like within the whole derivative?
What do you mean, why are we taking the derivative? What sign?
No, you have to. Okay, so you have to find derivative of this number.
Uh-huh.
So that would be 2.
Yeah.
And then you would multiply it
By half.
No, now you would multiply it.
On one, like, how you do equation, asking me for a derivative or not.
Okay.
Not
They're
a-
not, they're just saying to plug the pi.
You have to do this.
But it says like
Same thing as
like
zero.
the derivative
And
of
so-
pi over
Okay,
2.
you spoke up like saying it was wrong, you didn't have the correct answer.
So it would be 2 cosine.
Hey, why are we taking this?
Yeah, I'm thinking of 2 cosines for that.
Okay, good. So that was like maybe step 2. So maybe don't erase all that yet? Maybe. No rules. Who has something that they want me to check if it's right?
Am I tweaking or is that?
Then question number 1.
And then it would be two, I'm sorry, no, my bad.
Alright, now go to 3.
Okay. Okay, so that'd be cosine? Okay. Minus.
1A.
Because it would be, no, because sine is negative cosine, so it would be negative
Right
cosine
answer.
2 minus plus cosine 0.
Cosine.
Isn't it 0?
Except for R.
Can I ask you a question?
Yes.
Did you do everything it says to do up there in the order it says to do it in?
Read question, talk about question.
You have to get the
We
direct.
talked about the question.
Anytime.
We have to write down steps to
They
solve
give
it.
you like M
What does she just mean like this?
Talk verbally. Tell me what the steps are on paper.
Well, she also said write down the steps to solve it.
Right. Well, I said verbally, but I mean like use your words to describe what the steps are going to be before you do the algebraic and calculus steps.
Oh, okay.
That's what number. Yeah.
Don't do that.
Okay. Okay.
Who's missing today?
Do you just want to write that down on the side?
Let's do like an arrow. Because
Yeah, like
24.
That is like it is.
Hold on. On this one, this was the. Oh yeah, so we do have to.
Go back down.
So we do have to integrate. But we have a graph so we can describe it. No, we can't find the area on the graph.
Negative 6. That's not even on the graph.
That's the graph though.
Wait, f of negative 55, isn't that negative 4 top bound and bottom bound negative 4? Because think about it, negative 55 divided by 5 is negative 11, plus 7 is negative 4.
Negative 55 divided. Oh, it did divided by 5.
You're good. Negative
Yeah.
11 plus 7.
So it's just
negative
0.
Plus
Yeah, it's
7.
0. Good
He's
job.
right. He's right. He's right. He's right.
It's
He's
just
right.
0. 12, yeah, so like part of 12 is 0. And then f of negative, so that'd be negative 2, negative 4, and then just plug that in the calculator, right?
No, we don't need to do that. Yeah, we don't have the.
Oh, yeah,
so
we do the
have
graph.
to. We have to use. The
Okay, so I'm find the area from negative 2 to negative 4, which we have to use like pi and all that.
Negative 2 to negative 4.
Yeah.
That should be negative 4 and negative 2.
It's the same thing.
No.
Either way, you
Actually,
just
no.
need to take half of a semicircle, so you need to take a quarter, so it's 1/4 times r squared. R is 2. Huh?
3 for 3 on 1-1.
you plug that into.
No, only if it says derivative 1.
Yeah.
These are just normal
Yeah,
ones.
these are normal.
So if it's negative 4 to negative 2, then we just take 1/4 r squared. R is 2. 2 squared. 4. 1/4 is 1.
But
So 1 pi?
No, there's no pi when you're taking the.
Pi r squared is for the. Are you trying to get a half circle or a semicircle?
1/4.
We're taking a fourth.
Wait, it's just it's negative 4 to 2, so it's a fourth of a circle, so it's 1/4 of pi r squared.
Oh, there is a pi, so it's 1 pi.
And
So
r
it's
is
just pi.
2, so it's 4 pi. It's just pi. Yeah.
Yeah.
Just pi?
Yeah, which is pi? Yeah, 1 pi is pi.
I didn't know there was a pi in there. I thought you said pi was only in
put
circumference.
it in
Yeah,
whatever.
that's negative. That's a 2. You're talking about 2 pi r squared. There's no 2 pi r
Oh,
squared.
there's no 2.
Alright, so the next one, so the next one is from 0 to negative 4. So you find the area from 0 to negative 4, which is just half of that circle. So
0 to negative 4 is.
It's 4 pi.
It's 1/2.
Oh, wait.
It'd be
No,
2 pi.
2
It'd
pi.
be 2 pi.
2 pi. And then for negative 25, you would do 2 to negative 4.
2 to negative 4. Okay, so we know 2 pi plus to 2. That's a triangle with a height of 3. 3 times 3, 6 times 3. Or divided by 2. It's 3
plus pi.
So it's 6. Yeah, so it's 2 pi.
Subtracting from 0.
Because you're gonna get 4 or no?
For which one? 6. What? It's negative 4 minus 0.
No, why did we get? This is 2 and 2. So
I stopped because you did what she did what you were explaining. You're good. You're good.
Are you sure?
Yes, because look,
1,
over 2 up 2.
2, up 3. It's
Too long.
Upper minus lower.
So then is this like the same steps as before, like integrating and use FTC?
Not even, it's just use the FTC.
Can we get
I'm pretty good with unit circles.
this is the first part of 12.
Okay, 12.
Do it.
Do it. Tell me what you're doing.
Plugging in the set value into all of the x's.
Does that make sense?
Yeah.
Not really.
So
Okay, just do it on paper and then I'll get it then. Yeah, just do it on paper.
Wait, cause I'm just doing this. I get what you're doing, sort of. I'm going off what you said.
yeah, upper F minus lower X.
Okay.
I knew it.
I think I'm good at showing my work. That's probably why.
It's definitely 40.
It's just double the previous one. That's what I
Don't get
told
the
you.
cards. Get those cards up.
What I'm talking about. But were the rest driving the same thing?
That's the only one that didn't match.
Okay.
Here's what it was though.
But how come I did 35?
So,
It goes negative 45 down to 45. It goes like 20 or 10.
I am good at
We just started. Why is there floating into it here?
because I just have incomplete thoughts most of the time.
Okay.
Yeah.
Yeah.
You just plug in the numbers.
Let me revise that real quick.
And tell where all the x's are. Alright.
Okay, Laura, what did you do then? Did we not get the same answer? No, I told you.
It's basically the same thing.
I've never really seen it out here.
Yeah, it's
Just replace the F of negative 2 with F
You're not speaking words. That doesn't explain what you're doing.
So you plug in your negative 1 goes into your x-ray. You know that. You know that. I know you do. And then I swapped them. I did diaper bound. I get that. Whatever. Actually, I don't think you were supposed to do that.
I don't like having stuff.
Yeah, you probably should have done that. Because negative 3 is slower. You have to swap. Yeah. Because this should go
For this one, we just take derivatives.
Yeah, okay, here, I just.
And so then I just did that equation up there, and then I put as my upper bound minus f and my lower bound. And then on there was 0.
So what's our step?
Your upper bound should be negative 1. Your lower bound should be
Yeah,
negative 3.
I think the negatives are confusing me. I thought that now.
So this should be
Which column are you referring to? You're jumping between problems. 7. So you were still on 7? Yeah. Okay. It's missing f of 0.
So this is gonna go here, right?
Number one.
Does that make sense? On yours, what does that look like? That's right. And then what are you gonna do next? That's right, that's your answer. Yep, that's how you got this. So now you're gonna go to read, and you're gonna use what you just found, but now you have to manipulate it with.
The derivatives, is that what you said?
So help her, you explain what you did to her, and make sure that she knows that.
You still keep this too, and then you just close the pi
Well, okay, so I need you, tell me, you have to have an argument to your trig function. And then that 2, I feel like, is the derivative, right? So maybe you put that in front. So one of those 2's goes in front, but one is in the argument of the trig.
But that's the whole thing.
So what does that look like to you?
This area down here would be negative.
Yes, yes. So now, what are you missing? What does it look like you're missing there from that one above?
The 2 in front of it.
That is.
Or maybe you want to change
It's
your.
cosine pi times 2. It's cosine pi times 2 because you just plug pi over 2 times the thing, and then you can just do that on the unit circle.
So fix maybe your what?
Is the 2 inside the cosine?
Oh,
Okay, so
yes. It's
there's
inside.
2 2s.
Yeah.
Okay.
Yep.
Because the way it's
Yeah.
written there on that last set, are you looking at number 2 or number 3?
I'm looking at number 3.
Okay. Because the way I'm reading that is I can't tell if that 2 is inside the cosine or outside of the cosine because of where your parentheses are.
That's right, cosine of pi is negative.
Oh, it's outside.
Yeah.
It's times
So,
2.
when
And that's
you gotta
supposed,
be
that part's
careful with
supposed to be
your
outside.
averages.
Okay.
You should put in the pi
Okay.
When,
here,
when
and
it
then
says
that would
2x, you have to
Okay.
multiply by 2
Sorry.
first, and
Thank
then
you.
you evaluate the trig.
Okay,
Like
thank
you did.
you.
Good, yep, good clarification.
I just like to do y equals because then you can do,
Wait for number 2.
yeah, and then you can just do choose my values and just plug in all those values. It's quicker. But I'm getting
Alright, so I want you guys to explain, let's do 4 together here. So you're doing 3, right? So the integral from 3 to negative 3. What are you looking at? What are you gonna take? What did they give you? Let's put this over. Can I see this?
This is 4, you're right.
Alright, so they gave you this graph, right? What is the deal with integrals? Or tell me what you did first to get 6. Okay, so how did you get the value? I know, but what did you get for it?
I don't want to do all that.
Okay.
Or did you just add 3 and 3 to get 6? Okay, so this is the name of a function. So we have to go find that, but also we can't integrate this because here's the deal, they did not give us a function. They only gave us the graph. So area under the curve from negative 3 to 3. So that's what you're going to look at. And these are going to be estimates, but what do you notice on this one in particular? From negative 3 to 3, what do you think your answer is going to be there? 0. Okay, because everything on top is going to disappear with everything, right? If you're under that, it's negative. So are those symmetrical? Yeah, so that would be 0. So on the rest of those, you're going to do the same thing, except now you're going to just add the little box. And again, it's going to be a range of answers. So like if you say 2.5 and I thought it was 3, 2.5 is going to be correct, right? There's a range there. Because that graph is, I don't know, 30 years old.
I'm putting you in the spotlight again.
We are confused on anywhere to go.
There's not much to look at.
Huh?
Not much to look
It
at.
says,
Yeah, I don't
function f of x
understand how you
plus
do number 2.
the integral of ft divided by t
Because
squared
the
equals
FTC
2
wouldn't
squared x.
really.
Okay, so forget about everything except.
Okay, wait.
How would you make?
You're working problem number 1, and inside number 1, you're looking at number 2.
We've been doing.
We're working.
You
We're
take the
working.
derivative.
Take the
In, or
Yeah.
we're
So
working.
this is an equation.
Right.
What did you learn?
Okay, Roman numeral 1, question number 2.
We're working Roman numeral 2. Yeah.
Question number 2. Oh, question. Oh, okay. Sorry.
Divided by x squared.
But if you're doing Roman numeral 2, you're not going to do Roman numeral 3, right?
There we go. That is
I like to joke
We're
around.
kind of just jumping
But wait.
around. We're grasping.
What did those directions say? What is, on the board that were posted on the board and now it's in sleep mode? What did the directions say that were up there? Do you remember?
Yeah, discuss.
Okay.
X to the 1/2.
It's kind of the same problem. You take the derivative.
You're gonna probably need that, right?
I think you could derive both sides to get rid of the
Ms.
integral.
Reddington?
Yeah, so then you would get f of
So when I take the derivative,
f
that's our
equals
answer? Like, is that?
2x minus 2.
You have to, if there's anything with it, you gotta
Yeah.
that answer.
So that was
So again, we would be doing more algebra until we get to
I'm pretty sure.
f of x
Okay, so we need to move the 6 over and times this x squared. Well, yeah.
Because if you did it the other way, you get the same answer as well.
Move the 6 over. We got 6 here.
So then to number 4 is just the same thing. So take the derivative and
you said, do I said, what do you do? You
Yeah,
said
take the derivative of both sides.
I said, take the derivative of everything.
We want to do what's 3? It's pretty complicated. Yeah, she wants us to do 1 through 5.
You have to take the derivative of all of it.
If we're doing
Or you
algebra,
want to
more
take the
analysis.
derivative.
Okay, well, I just looked over.
So
It's
therefore,
not.
you gotta take the
It looks
derivative of
tough,
everything.
but it's not really.
You can't have part of an equation be a derivative and not. So what's the derivative of 6? Yeah.
So we just have to move the x
See,
squared.
and when you first started, you just said f of x. So why'd you add back into
4, -2.
So now you're just gonna have to multiply both sides by what?
X squared.
That's right. And if you got the derivative of 2 radical x right, then your answer is correct. Right, but you gotta get that right.
We times the other side by x squared.
Okay, so if you.
Alright, how we got over here?
Doing number 3. We just got done with number 5.
Excellent. Is 5 good?
We're not sure. I said to derive both sides.
You said what, both sides?
Derive both sides. Get rid of the integral, and then just derive that.
Yep.
That's you get ft equals that derived.
Right, because
Or f of x.
if you wanna do something, you notice that if you take the derivative like you said, then you're gonna get what you started with.
Correct. Yeah.
Or what you want. And so, but you can't just take the derivative of one side and not the other. It's the same thing from like algebra 1. Whatever you do to one side, you have to do to both. So then that makes that problem easy, because what did you get for the derivative of the second side?
To be 2x minus 2. Yeah.
So then for number, for this one, are we just doing the same thing? We move the 6 over?
For that one,
Okay, that's 4.
do the same exact thing.
Okay.
You're gonna take the derivative of both sides.
Okay.
So, might as well do that one right now, because you're thinking about that.
Yeah. The 6 wouldn't carry.
That's 6 minus 1. But I guess if you were to move it over to the other side, it would matter. 2 squared x minus 6, then it would cancel out.
That one? So, this one here, this one, you're not deriving it.
Yeah.
So this is the integral, which means that you're looking for the area under the curve. And so you integrate, and then you do f of b minus f of a, the upper bound minus the lower bound. They would ask you this.
That when there's a t in it.
Look, they would ask you number 1. See how there's no derivative? And m is an integral. So what you want is you want to see the difference between 1 and 2. Because see how 2 says m prime? So then that would be over there. On that one, see how in front of the one by the clock, it says dx dt, and you're going to do the second fundamental theorem. So you do the one under the clock when it asks you questions like 2. You do the one on the front board when it asks you questions like 1. So on those, they're not going to be saying anything about a derivative. Does that make sense? Alright, so if we just, you look at this one and tell me about 4, 5, 6, 7, 8. Which one are you going to use? Are you going to use that one or that one?
So something minus 2 has to equal 17, right?
FTC, because they're not.
That's right. That's right. That's right. Perfect. You got it. That is going to be important, right? On Friday. Good clarification. What do we got? Who has questions?
We're given f. We're not given the integral of f. We're given f, not the integral of f. So you have to calculate the area of f, which is impossible.
So does that mean it's 29?
Not given the
F of 4.